Hi, my name is Hamza Khan, and for the assignment 2, first I upload the CSV file, and next after we have the correct file path, we use the pandas to read the CSV file and store it in the data frame IRIS. And for 1C, once the data is loaded, we can call the head show the first 5 rows. And for 2A, in the data set, the last column contains string values representing the flower uh, species. To train the model, it's easier to work with integers instead of strings, so we map each string to number. For 2B, after converting the label, is like we just print the first 5 rows again. And for 3A, the first 4 columns represent the features of the flowers, so which we will use as the input data for the model. And we're just selecting the first 4 columns. And 3B, we just select the last columns as a label and call it Y over here. The only difference is the columns. For 4, yes, for 4 is we will split the data set into training and testing segment with 20% of the data. So here we um, just get the train test split function from sklearn model, and this will handle this split. Uh, and for 4B, after splitting the dataset, it's important to inspect the first few rows of both the features and the labels if to see if the split is correct. And for 4C, to verify the split, we check the length of the testing, training and testing data, and um, here we can see the length. Next, yes, one. So here is just converting Y train and Y test. So one hot encoding is necessary for multi-class classification. So here it converts each label into a binary factor where the correct class is represented by 1 and all the other is 0. Next 6A, over here we define a simple feed-forward neural network with 3 layers. The first 2 layers have 100 neurons each and use ReLU activation. The last layer has 3 neurons corresponding to the 3 classes. 6B, here we switch the optimizer from Adam to RMS prop. 7A, we just we train the model for 20 approach and use batch size 10. For 8A, here once the training is complete, we evaluate the model on the test set and see the accuracy. 9A repeats the step with the model having similar layers. So with the smaller hidden layers, 10 neurons, and to see how the model performs with less complexity. 9B, we compile and train this new model just like before and see the performance. And for the questions, for the how layers and hidden units impact accuracy. So more layers and neurons allow the models to learn more complex relationships in the data, and but too many can lead to overfitting, while too few might not capture enough details, leading to underfitting. And for the second one, like, do we always suffer from overfitting? No, overfitting happens only when the model um, fits the training data too well, including noise, which affects the performance on new data. And next, how to detect overfitting. Overfitting can be detected if your training accuracy keeps improving, but validation accuracy stops improving and start to decline. Um yeah, that's it. And for the how can we reduce overfitting? You can reduce overfitting by using techniques like early stopping, adding dropout layers, etc. And for the 10B, first we have to change the optimizer for the question 9. So if I go to the 9B and I change this to Atom and then run it, so I can see over here that so when I switch from RMS prop to Atom, the accuracy jumped um, because Atom works better because it adjusts the learning rate for each parameter individually and keeps track of the both gradient and their change. Next, we change the number of layers and the hidden units. So where is the 9A? Yep. So here when we add one more layer, here we can see the total params have been changed, and same with the uh, changing the hidden units. When we run it again, they have been changed too. So this is because like when we add more layers introduced additional weight and biases between layer. So the number of parameters increases with each new layer based on its size and previous layer. And the increased hidden units add again more weight connections between layers and more biases for each unit. This directly increase the model parameters. And next, for the number of approach and batch size, over here when we change the approaches and run this again, we see the test accuracy has changed, and if we increase the batch size, the test accuracy stays the same. And this is because like when increasing the number of approaches allows the model to train for more iterations, which means it has more opportunities to learn from data. And for the batch size, changing the batch size affects how many samples the model process before updating its weight.